take a look at horizontal and vertical translations. So horizontal translations, you will see something like f of x minus h. So the biggest thing that I want you to notice on here, just to make this little quick, is that if you see a negative inside, that is going to go to the right, however many units it is. Then if you see a plus in the inside, then that is going to go to the left. Okay, then for vertical translations, that's going to be on the outside. So if you see an f of x, that function, and you're adding a value, a k value, just a number at the end, then that is going to go up. If you see f of x and you're subtracting, it's going to go down. So let's practice a little bit. Write translations of functions. Let f of x equals absolute value of x. So the first one, write a function h whose graph is a translation 2 units to the left. So 2 units to the left, meaning we're doing a horizontal translation just like it is up here. So horizontal has to do with something that you're doing inside with the x value. So it's inside the parentheses. So to the left, and if we look up here, left means we're going to add a value with the x. So 2 units to the left, this is what we write. Our g of x equals absolute value, that's what we're using, x, and then to the left is plus 2. And then you can read that, right? We know that that is left 2. Next example, write a function g whose graph is a translation 3 units down. If we're going up or down, we're looking here at our vertical translation, and it has to do with adding or subtracting on the outside. So 3 units down, that means we're going to subtract a value at the end. So we'll write this. We'll write g of x equals absolute value of x, and 3 units down is minus 3. So anything that's a horizontal, left or right, you're doing something to the inside, and it's opposite signs. If you're going up or down, you're just adding or subtracting at the end. Subtracting is down, and adding is up. So I want you to try these next 4 examples here. So pause the video, and then when you come back, I'll have the answers for you. So if you try this out, 2 to the left, you would have x plus 2. We went over this already. 3 units down, 3 down. 9 units to the right, so we're going to subtract in the inside, so absolute value of x minus 9. 7 units up, we're going to add 7 to the end. Now, letter E and F, we have different functions we're working with. So this one, we're working with x plus 3. So we know it's already shifted to the left 3, and now we need to move it 5 more units to the left. So we're going to the left, we're adding that 5 into the inside. So notice I have the x plus 3 already in there. Then I'm going to add 5 more units to the left. So therefore, you add that together, we get absolute value of x plus 8. And letter F, we're moving 11 units down. It's at plus 2. So when we move it 11 units down, plus 2 minus 11, we would get absolute value of x minus 9. Let's take a look at reflections. So reflections in the x-axis, that means you're going to multiply a negative to the front of the entire function. The thing that you need to remember with this one is that you have to distribute to the front and the back, and not to the inside. So distribute front and back, and then not inside. Now, with reflections in the y-axis, what we're doing is we're adding a negative, but it's only to the x. So you don't change anything else, just only to the x inside. So don't distribute or anything else. So let's try some of these out. Writing reflections of functions. So write a function g whose graph is a reflection in the x-axis of the graph of f of x equals absolute value of x plus 3 plus 1. So to do this, you're multiplying a negative to the entire function of x plus 3 plus 1. So I said earlier, you have to distribute to the front and to the back. So what that means is it just changes the signs to the front and the back. So now your new g of x will actually be negative absolute value of x plus 3, and instead of a positive 1, that changes to a negative 1. So letter B, write a function h whose graph is now a reflection in the y-axis. So the y-axis, you remember, you're just changing what's inside with that x. So quickly, to do this is actually pretty fast. So our h of x is going to be the absolute value of negative x plus 3 plus 1. So the only thing that changed is I added a negative to the inside. That's it. So that is in the y-axis. So with the y-axis, you just add a negative in front of the x. For the x-axis, you have to distribute. So try out letter B, C, and then this is actually D and E, and I'll go over the answers as soon as you come back. So now if you try this out, reflection in the x-axis, so notice I made it in pink what changed. So nothing in the inside changed. Reflection in the x-axis, you distribute to the front and the back. Nothing else changes. Then here, you do the same thing. Reflection in the x-axis, you distribute that negative to the front and to the back, but nothing else changes inside. So reflection in the y-axis, so I told you before that what that is you're just adding a negative inside with the x. So notice that's the only thing that changes. I added just a negative in front and a negative in front, and that's it. Nothing else changes. Vertical stretches and shrinks. So with a vertical stretch, that's going to be a number that's greater than 1. So you're going to see y equals a, and we're going to multiply it to the entire function. It's very similar to our up above where the flexion in the x-axis. Then we have vertical shrink, and so you'll see something where it's still an a value in front, but it's a fraction. So say, for instance, it's like 1/3 times the entire function. So let's try this out. A vertical stretch of the graph of f by a factor of 2. So to do it piece by piece, if you wanted to write it, we're going to take 2 and multiply it to the entire function. So I'm going to take 2, and then I'm going to multiply it to x minus 3 minus 5. Again, this is similar to the reflection in the x-axis. We're going to distribute it to the front and to the back. So what this becomes is g of x equals 2, absolute value of x minus 3 minus 10. So the things that change is just the 2 in the front and the negative 10 at the back. Vertical shrink by a factor of 1/3. We're still doing the exact same thing that we did before. It just has a different word attached to it. So what we're going to do is we're going to multiply 1/3 to the entire function. So what this is going to look like is 1/3 times the x, absolute value of x, minus 3. And then we have to remember to distribute it to the front and to the back. So this changes to g of x equals 1/3 absolute value of x minus, now remember to multiply 1/3 times 3, you just multiply straight across. So that would be negative 3 over 3. And remember, negative 3 over 3 is just 1. So this is a g of x equals 1/3 x, 1/3 absolute value of x minus 1. So these are all very similar. You just take the function, take the number that you're stretching or shrinking it by, and multiply it to the front and the back. So try out these next examples below, 4 of these. Pause the video, and when you come back, I'll have the answer for you. So if you tried this out, you're multiplying by 2, so you multiply to the front and the back. So this becomes 2 times absolute value of x plus 2 minus 6. And then here you multiply by 2, so you distribute, and you get 2 absolute value of x minus 6 plus 14. So I hope you notice that the pink is what the new parts of this function becomes. Letter D is very similar. We're just multiplying by a vertical shrink, 1/5. And so when you multiply, you would get negative 10 over 5, and 10 over 5 is 2. Here you do 1/4 in the front, and 1/4 times negative 8, that's negative 8 over 4, which is negative 2. I hope this helps. Thanks for watching.